I have already mentioned two static nonlinearities, which are the saturation and the dead zone. Let us see what their effect is when we have a sinusoidal input. If I have a sinusoidal input with an amplitude which is lower than the saturation values, then the saturation will have no effect at all in the output. If, however, instead of this, I have a sinusoid with an amplitude which is larger than the saturation values, I will have no outputs larger than the upper saturation value, and I will have no outputs lower than this lower saturation value. So I will end up with a truncated sinusoid like this. If I have a dead zone, then the effect is felt not for large values of the sinusoid, but rather for values close to zero. It is when we cross zero that the system will, let us say, get stuck, not move, and we will have an output which, again, is not sinusoidal. Now, both the saturation and the dead zone are static nonlinearities. Surely you already know the difference between a static and a dynamic system. In a static system, the output only depends on the current input, while in a dynamic system, the output also depends on past inputs. Let us now take a look at a very usual nonlinearity which has a dynamic. This is a nonlinearity called hysteresis. When in the presence of hysteresis, we will have one behavior when the input is growing, that is to say, when its derivative is positive, and a different one when it is decreasing, that is to say, when its derivative is negative. So let us take a look at the effect of hysteresis in a sinusoid. When we are going up, since here we have a value which is lower than x, we will have something like this. We will grow only until we reach the point where the derivative changes its sign. And here we will change from this curve to this one here. And we will only move after reaching this point and then going down until we reach another change in the sign of the derivative. Then we will again change the curve and we will again get stuck here because it is here that the derivative changes sign. And we will also have an output that looks like a truncated sinusoid. Hysteresis can be found due to a number of reasons. It appears, for instance, in viscoelastic systems, but it can also appear in many mechanical and mechatronic systems because of a phenomenon called backlash.